Hi, ever wondered how to leverage the Python standard library via WebAssembly? Well, today we're going to do just that. We're going to use spin. So the first thing we do is we create an empty application, and this is using the HTTP empty template. So we've given that a name and a description. And now we should see a folder structure that looks something like this, basically an empty application with a spin manifest file. Now, from there, we can add components. So we use the spin add. This time we're going to add a HTTP Python component, and we'll call that the calculates greatest common divisor. There's the endpoint for reaching that. So now if we look at the directory structure, we'll see that we have a component in there alongside the manifest. So let's go and put the Python code into the greatest common divisor function. And you can grab that from the blog post. It's fairly straightforward, just cut and paste that in. And now let's go ahead and create a second component. So this time we're using simulation multi-server queue as the name. The description, this is essentially calculating arrival times. We give that a endpoint, and we'll call that simulation multi-server queue. And at this point we'll see that the directory structure is that we have a manifest and we have two components side by side. So let's go ahead and pop the Python code for the simulation multi-server queue in. And again, you can just go to the blog, which I'll link to in the description, and copy and paste the code that we've already written if you want to try that out. There's also some examples of the data that we pass in. So this top section here processes the request, and you can just use those values if you like. Okay, so from here we want to build this application. So we use the spin build command. Now once that's built, we can deploy that straight to Fermyon Cloud. So instead of running it on localhost, we're going to type spin deploy, and that'll push that up and create an application in the cloud for us. Now once that's ready to go, we'll receive back some information about the application, so a couple of URL endpoints that we can use, and obviously we have to construct a little bit of JSON data to go in as parameters for these functions. So let's do that. So the first one we're going to do is have the GCD endpoint here, and we're passing in a list of numbers, so 12 and 18, and we wanted to find the greatest common divisor of those, which is 6, so that's correct. And if we format that JSON string that's returned to us, we'll see something along the lines of this. Alright, so for the next thing, let's go and do the simulation multi-server queue. This time we're passing in a little bit more complex JSON object. So you can see here we've got a few different values. So we run that request, and the application in Fermyon Cloud will return for us the mean weight, the max weight, and the quartiles there. And once again, if we format that JSON string that's returned, we'll see something along the lines of this. So why not go ahead and try out some of the other Python libraries? I'll leave a link to the blog article in the description, which explains some of the nuances around this. Happy coding, and thanks for watching.